And welcome back. As we go ahead and continue to look at different ways to debug, today we're going to specifically focus on loop bugs. So obviously loops are a very important piece of our programming techniques, and a lot of times we have to fix issues related to those loops. Loops typically are either going to run for a finite or an infinite number of iterations, as we have already seen. For example, if we want a loop to run for 10 iterations, that would be a finite iteration, or if we want it to run forever, well, that'd be infinite. Now, what happens though if your loop never meets the condition to exit that loop? Let's just say for a finite loop, when we have our known iterations, this likely means that the loop is either running forever, or maybe it's not running enough iterations. Maybe you want it to run for 6 iterations and it's only doing 5. For an infinite loop, maybe we have it running infinitely because we're getting user input up until a certain point. But when we say, hey, we want this loop to stop getting input, that loop never exits, even though we have a condition set up for it to leave. And, of course, there's always the problem, what if that loop doesn't execute at all? Which, of course, a lot of these are going to come back to how we are handling that Boolean expression. So when we look at loop errors, the two most common types of errors that we occur outside from a Boolean expression are going to be a infinite loop, which of course you can have positives for, or an off by one error. Off by one errors are ones that might be a little bit more tricky because our loop body is going to repeat the code either too many or too little times. So, this is of course saying it's going one too many or one too little, or some variation of that. This is, of course, going back to that Boolean expression that we have controlling the loop iteration. So the Boolean expression is a very important part of our loop. Always check your output with a specific check to make sure you have if you have an unnoticed off by one error. The most common cause of these errors, of course, is using something like an equals equals or a not equals to in our Boolean condition. It can, of course, happen in other ways, but that's one of the first things. In fact, that's why they say if you're going to use Boolean expressions to control things like loops, try to avoid using equals equals or not equals if possible. So let's first look at how to fix an infinite loop. So in this code, all right, we have a very simple program here. It says while num is greater than 5, system.println num. You notice the loop never exits. All right, and this is a pretty low-level thing, but of course it could be something that you easily forget. What is the thing that we forgot to do here? What is the example that we need to do here in this code? Well, it's a relatively simple fix. The loop never iterates. So an infinite loop has been generated. And again, there are times when we want infinite loops, but if you find yourself having a loop which doesn't exit, first thing to check is to make sure, of course, you are iterating that loop. Make sure that you are creating conditions for that loop to exit. All right, so we're going to fix this code by adding a proper either increment or decrement statement, depending on how our variables are set up. So this is just one example. While num is greater than 5, system.println num minus minus. So we're assuming that it's going to start at some value that is, of course, going to get that to decrement. So for example, if let's say we had 10 and we are going down. All right, so 10, 9, 8, 7, 6, all the way down until we get to a value that's no longer greater than 5. Now, what about an off by one loop? So if we look at this code, all right, and let's say we only want this to go 5 iterations, and we're going to assume for this example that num has been initialized to 0. So we have while num is less than or equal to 5, system.println num plus tab, num plus plus. So we have, of course, are iterating, so that's good. But what is the issue here? All right, we said it's an off by one error, and if you remember with an off by one error, there's a key thing that we really kind of need to home in on. And so the way to start this is kind of first look at our output here. All right, if we look at the output, we'll see there's actually 6 outputs, and therefore, because there's 6 outputs, we have 6 iterations. The outputs, of course, being 0, 1, 2, 3, 4, 5. So with this off by one loop that we are looking at here, how do we fix this? Well, if you remember, there's a Boolean expression. It includes 5 as a value. So therefore, if num starts at 0, the loop will take in 1 too many iterations before it exits. And so we change that iteration. If you notice, we have our while num is less than 5, it was less than or equal to. So it's a real quick and easy fix here because before I was just simply going 1 too many. And that means it was including 5 as a value. So what about our equals equals or not equal to errors that we talked about? Well, if we look at an example here, the following loop is using a condition exit. So we have while true. This is now print line num plus tab, num equals num plus 2. So we're iterating. If num equals 10, break. All right, cool. So this does have a condition set up for us to exit out of this loop. However, there's a potential logic error that would prevent that loop from terminating if we have this code as is. And you might be able to look at it and see right away what is that thing that's going to prevent it from doing that. So how do we fix this one? This one's a little different. Well, if num were to start at a value that reaches 10, such as 0, there's no issue because it's going to go 0, 2, 4, 6, 8, 10. Oh, 10, break out of the loop. However, if num starts at a value such as 1, it's never going to reach the condition to break out of the loop because it's going to go 1, 3, 5, etc. And it's just going to skip right over 10 because it's going to hit 7, 9, 11, never going to hit 10. This can be addressed, of course, by either modifying the Boolean expression of the loop itself, because remember, it was just while true. So we could, of course, modify that to have some sort of value that's going to allow that to exit out loop. Or we can create a branch of the if statement to address the shortcoming. So we could have some sort of thing that is, we could still keep our if, it's 10, we're going to break out. And we could have like an else or an else if that maybe has a inequality expression. So maybe it's like else if, num has reached 100, we're going to exit out of this loop. So there's still some sort of stopgap to keep it from going onward. We could also do things like nesting it to see if it's a positive or a negative value. And then, well, if it's a positive value, we're going to go to 10. If it is, for example, a negative value, we're going to have it stop at negative 10. If it's a even number, we're going to have it behave one way. If it's a negative number, it's going to behave a different way, or odd number. So these are all, again, things that you can handle within the code itself. And last but not least, I want to go in Eclipse to just show an example of one of these errors. But this time I'm going to show you with a for loop because, of course, all the examples we saw at this point were while loops. So I want to give you a for loop to kind of look at. And with this for loop, one of the things you'll notice is that we have a potential error here. And that error is, if you probably guessed it, related to our Boolean expression. Because the nice thing about for loops, we don't have to worry about iteration errors because that's built right into the structure of that for loop. And so we have, of course, an I++ here, which is great. And so I'm just going to go ahead and run this code. And it says, please enter a number to test the code. So let's just put in 5. And you'll see one of the cool things about this, because I'm already having effectively a built-in trace statement, it's telling me exactly how many iterations this is going through. Now, if I had just put out I, it would have started at 0. It would have said 0, 1, 2, 3, 4, 5, which is fine. I would just have to recognize that. But because I did I+1 here, it tells me exactly how many iterations are here in this loop. So I can look and say, oh, I have 6 iterations, which means I probably have a off by 1 error, which means I have to look at my Boolean expression. Oh, I have a less than or equal to. Now, if I wanted this to go for 6 iterations, so whatever the user types in +1, that's fine. But if I want that to match, I need to adjust that Boolean expression. And so now if I rerun this code, you'll see we now get 5 iterations. So again, little things like this can make a big difference in our programming, and it's always important when we start running into potential issues with loops to check our Boolean expressions first.